So my name is Rhys ARKINS. I'm an Australian living in Stockholm. And today I'm talking about software dependencies, software vulnerabilities, and hopefully some new ways of thinking about those. So the reason I'm here is I built a tool called RenovateBot. It's an open source tool whose purpose is to automate software dependency updates. And it's used quite widely by a lot of big companies these days, and so it's something I think about a lot. And I'm going to talk about not so much RenovateBot directly, but software dependencies, vulnerabilities, and where I think the future is heading with that. So to start off, I wanted to bring everybody up to hopefully speed on this concept of software dependencies and automation. So first of all, when I say dependencies, it's kind of a fancy way of saying other people's code. Other people's code that you use to build your software. There's something like 97% of professional software developers use dependencies in their code, and I actually haven't met any of the other 3%. And basically, if you write software, you use other people's code at some point. And so in the early days, you would find code that was useful to you. If you were building a website, it might be something like jQuery, and you would take it, you would copy and paste it, assuming that was legal. You take it, copy and paste it into your project, and generally you would kind of forget about it. You certainly would often forget to update it. So this was the original way that people used software dependencies. And we evolved a little bit. Sorry. The second approach is then with CDNs, content delivery networks. And so instead of copying everything into our projects, we would maybe find a CDN that hosted something like jQuery, and we would put a link in our website to it. But like the first way, we would generally forget about it. That was the way that would work. So enter early package management. In this sense, software registries grew up, and so you'd be able to browse a registry for useful components of software. You would pick one that you like to use. You would declare it in a file of some sort in your project. We call this a dependency file. Sorry. And you would get the latest version every time you installed. So this was a key part of it, was that you no longer had to really remember about it, because every time you ran install, you would get the latest version. Okay. So the problem with getting the latest version always is that you end up with a lot of what we call works on my machine problems. So, you might do a fresh install on a new laptop, write some code and it works, and then your colleague runs the same code and it doesn't work on theirs. It's generally a small problem. A much bigger problem is that you write code and it uses a certain version of a dependency, and then you run it on your test servers, and that uses a different version of that. And even worse, you push it to production, and your production code is using a different version to what developers are using or what you've tested. So this was the big problem with early package management, was it was a little bit like roulette in terms of what you get. And to summarize it, it usually worked. It did usually work, but the problem was sometimes it didn't. So now, what I'd call modern package management, this is kind of where we are today, and it's very similar to what I just described, but the big difference is that we generally lock dependencies. So you define the software that you're going to use, you maybe even define a range that you're happy with, you install it, and at that point you freeze it. We always say lock, but freezing sometimes can be an easy way of understanding it. And so you have this recipe in a package file that describes the versions you're going to use. But then your lock file actually describes exactly everything that was installed at the time you installed it. And what this means is that you do get the same results every time. So I commit a change to a software project, my colleague runs it, they will install the exact same as what I was using. And most importantly, when we run tests, the tests will be run against the exact versions that I last installed, and the production will be run against it. So this concept of lock files gave us predictability of third-party dependencies, and it was a very important step for mature code. The problem is that it is frozen in time. So now I'm going to discuss what are the problems that still remain with this current approach to software dependencies, and also the different ways that people have to solve it. So I'm introducing to you someone I'm going to call Bob. I picked a stock photo that looked a little bit like me, so I'm not picking on anybody. And Bob uses modern package management, so he's pretty happy. He's nailed it. You know, if you're a developer and you use dependencies like I just described, then you're basically using best modern practices. So that's Bob. Now here comes Bob's boss. And Bob's boss says, "Yeah, Bob, if you could stop using vulnerable dependencies in our software, that'd be really great, all right?" And it's not really Bob's fault, right? No one sets out to use vulnerable dependencies. And in fact, when he installed them, they weren't vulnerable, right? And he's frozen them in place with a lock file, as you should. But his boss has just told him that I have been told you've got vulnerabilities. And so to a software developer, vulnerabilities are a real big deal these days. The good news is that there exists services, sometimes paid, sometimes bundled, but there exist services to help you with that. I'll call them vulnerability alert services. Now, definitely not everybody uses these, but they're becoming much more common. So the way vulnerability alert services work is that they scan your source code regularly, sometimes even kind of instantly, like on every commit, and they send you vulnerability alerts. That's why we call it a vulnerability alert service. So they will tell you, they'll tell Bob's boss, hey, there is a vulnerability in this code. And sometimes, of course, this could be because you just introduced vulnerable code, but normally that's not the case. This is why it's so hard. Normally it's because a version that you've already been using was discovered by somebody to be vulnerable. So something that was fine yesterday is now really not fine. If you're lucky, these services will also tell you where to update. So it'll not just say, hey, you got a vulnerability in this software, but they'll actually say, like, here is a fix for it. Here is a patch, or here is a pull request. So this is a valuable service, and the companies that provide this are generally valuable. And so this is what I call the dependency fire drill. So that's the first part of the presentation's title. And we call it a fire drill because, you know, one day everything is fine, and the next day you've got a fire, and the alarms go off. And a fire drill is a pretty good analogy for it, because that alert might be telling you that the website that our company runs, that maybe even millions of people use a day, or maybe it's the app hundreds of thousands of people are using every hour, has a vulnerability, right? And it takes time to understand what the implications are of that. It takes time to update. And so people have this emergency drill where we know we have a vulnerability, but we don't know, should we be shutting down our website? Should we be disabling our app? What should we be doing? At least you know what you need to do. I swear this is moving by itself. Anyway. So here's Bob again, right? So Bob does have a vulnerability alert service. So he knows he's got a vulnerability, and that's good. The problem for Bob is that he just got told that he needs to update from version 1.2 to version 3.1.1. Right? So Bob is not going to have a good day at all, because version 1.2 might be 18 months old, because that's when it last got installed. It's 2 major version updates, which generally means breaking changes. You know, which literally means you're going to have to make changes to your code to use this new code. And there also might be 10 or 20 new features introduced in that time, which could be accidentally breaking or that it needs to review. So even though you've got a service that's told you instantly that software you use is vulnerable, that doesn't mean that it's over. The same problem still applies. You know, Bob's got to decide, do we shut down the website? Do we shut down the app? what is the risk here? Do we jump from one fire, which is we've got a vulnerability, to another fire, which is we just broke the website, right? So this is a really tough decision about what to do. And, well, like I said, Bob is not going to have a good day, even though he's got the latest best practices and they're paying lots of money for that. So now I'm going to introduce you to second character, which is Alice. Now, Alice is actually having quite a fine day. She's even got time for coffee, and she's smiling. She's also got a vulnerability, but the difference here is that she's just been told she needs to update from version 3.1.0 to 3.1.1. Right? Now, 3.1.0 was released a couple of weeks ago. They reviewed it, they updated it, and 3.1.1 is just like a one-line or two-line security fix. They found a buffer exploit or a regex or something like that. Normally, security fixes are actually very, very small. As you'd probably predict, they're only intended to fix the very minimum possible to stop the exploit. So from Alice's point of view, right, bad that you got a vulnerability, but good that you can basically inspect that code and accept that fix right away, tell the boss that you're not vulnerable right away. The risk of going from version 3.1.0 to 3.1.1 is far less than version 1.2.0 to 3.1.1. So the problem, therefore, the vulnerability alerts problem, and it's not really a problem with vulnerability alerts because they're essential. It's a problem if that is your only solution or your only process, is that you have no process to update dependencies unless they're vulnerable. By default, they sit there, and they might get updated ad hoc, but you have no process for that. So they only get updated if they're vulnerable, which means that normal modules are not vulnerable for a long time. They might sit for a year or longer. The second problem is that big version jumps are a high risk. So like we saw with Bob, when you've got to jump from a certain version, like version 1.2 to version 3.1.1, that's a very high risk jump. You're going from one fire, vulnerabilities, to another one, potentially breaking things. And the third one is that, and this is important too, not all important fixes in a library are necessarily vulnerabilities. So if you're only updating things when they're vulnerable, you're probably missing quite a lot of just important bug fixes and patch fixes which can be passed on to your users. So this is a problem with only taking vulnerability alerts as sort of like the only solution. So there exists another complementary approach, and this is actually where Renovate Bot comes in. This is called dependency update automation. So the idea of this, and this is what Alice was using, is that you can get pull requests when you have software updates. You still retain the predictability of builds. So if you remember in the old days, it was great because we would install and always get the latest, but the problem was we had unpredictability. We had lack of control. So you retain the control by having lock files, it's just that you were bumping them regularly in order to keep up to date with the latest versions of software. This itself helps you avoid dependency decay. If you build a software project or a website and you have certain versions of software that you lock in and then you leave it, you will experience decay over time. There will be bugs that don't get fixed. If it's a website, for example, there may even be like new bugs that didn't exist when you installed it. Like new versions of browsers may introduce problems in a library that previously didn't have one. So to not update is what I call decay, and by continually updating, you can avoid that decay. And importantly, even if you still think that the most important thing to you is vulnerabilities, by being completely up to date, or at least reasonably up to date, this minimizes the stress and risk of when you get vulnerabilities. So this is update automation, which I'm going to refer to now as the dependency fire hose, which is the second part, right? And we called it versus because now what we're looking at is like two kind of different approaches to minimizing risk in dependencies. One is don't touch it unless we know there's a problem. And number 2 is like a non-stop fire hose of updates. Now, don't get me wrong, there are ways to kind of minimize that fire hose, but essentially you've still got this problem that it's a non-stop flow. So the downsides with this approach as well is that the raw feed of updates in a software project can itself be overwhelming. It can be distracting to have non-stop updates as well, right? So it's not some kind of utopia. But also, if you're looking at risk, the earlier you update a new version of a dependency, the higher the chance that you hit a bug that hasn't been discovered yet. Bugs are not discovered instantly. We're not talking vulnerabilities necessarily. It can just be regression errors. So the earlier you adopt, the higher the chance that there's an undiscovered bug. Now, of course, that curve comes right down over time, but if you sit on the front of that curve, you're increasing the chance that there's something new that's wrong that you're introducing into it. All right, so then the goal, including of this presentation, is to try and find the balance between this, fire alarm approach and the fire hose approach. All right, so the answer, sort of, is what I call crowd dependency data. Now, you can think of it as like a kind of machine learning or artificial intelligence for dependencies. I think of it more as SQL queries that I need to write. It's really just statistics and how we can use those to lower our risk of dependency updating. So let's go back to Bob. So Bob now has not only a vulnerability alert service, but he's also got a dependency automation service. And he's received an update that there is, a bug fix for a certain library available to him. And all right, so now Bob has good tests and his test passed, so he's pretty happy. He just got notified of a patch. It passed the test. This is all good. But let's blow Bob's mind, right? What if we could also tell Bob, not only did your test pass, Bob, but everybody else's tests passed as well, okay? And this is what I'm talking about by crowd dependency data. So we've got these open source libraries that many, many people use. And although we have tests, naturally, we're usually trying to test our code. We're not really trying to test somebody else's code we imported. We generally like to assume that that's going to work. But also, at the same time, sometimes in order to test our code, we're going to run a lot of somebody else's code. So the chances that a regression error in a software dependency update is caught by everybody in the world is clearly much higher than the chances that you would catch it in just your tests, even if you think that you have 100% test coverage. Okay. So learning that everybody's test passed is a really great thing. But we didn't really save Bob from anything, right? Because Bob was already going to merge that update anyway. His test passed. It's a bug fix. He was going to go ahead. What would really blow Bob's mind, and I don't have another image of Bob, so I'm just going to have to describe it. What if we told Bob that instead of telling him that everybody's test passed, what if we were able to tell him that 20% of everybody's tests failed? Right. This is far more important data to Bob, because without crowd data on dependencies, without somebody saying this new version of React just broke a large number of people, then Bob would have gone ahead and merged that dependency and quite possibly put into production a bug that would have had to have been rolled back. So speaking of rollbacks, what if instead we could tell Bob that, everybody's test passed, but out of the people that updated to it, 1/3 have already rolled back. And the reality is we probably wouldn't put it like that to Bob. We'd actually just say to Bob, Bob, do not merge this update. There's something wrong with it, right? Because by being able to tell people this, by having a crowd data, we're able to save people from putting software live that they otherwise would have that has bugs. So let's look at then something else related, which is crowd adoption rate. So, if you want to understand users, you listen to them, right? You listen to your users. But if you want to really understand users, you watch what they do. There's a really big difference between what people say and what they do. Okay. So if we're thinking dependencies and dependency automation, what do people do? Well, they merge updates. So merging an update is a powerful indicator that the update is good. So we want to watch the percentage of people that merge updates. And for example, someone like Bob, after the first time that we told him that, hey, this dependency update actually failed for a lot of people, he might have an interest in saying, well, you know what? I actually don't want to know about updates until at least a quarter of everybody else has already updated to it. Like, don't cause noise into my project. Don't even tell me until there's an adoption rate above some threshold that I like. And people have, very different thresholds. So this would be configurable. So now we've got this idea. Let's let others go first, right? But it introduces a new problem, which is who goes first? If everybody said, I'm going to wait back on this dependency until a certain percentage is updated, you'd never have anybody updating. Right? But that question is actually reasonably easy to answer. What are the reasons why you would adopt something early? Number one is there's a vulnerability. I mean, everybody then should adopt it as early as possible. But number two is that it contains a feature that you're waiting on. It's quite often that people are waiting on features from libraries like React, like Angular, and so when a new version comes out, they want that right away. They want to bring it in and test it and use it. So that's a good reason to early adopt. And the third one is that it fixes a bug that you know about. Right? So these are three good reasons why you would have early adopters take risk in adopting first before the others. So then the next question. Why do open source upgrades actually have to be so risky? Why do we take it for granted that if you're the first to update, that's such an enormous risk? So let's look at how we perceive risk today of taking software versions or using software dependencies. So the way we perceive risk is that you use software X, somebody writes an exploit into software X, all right, and you're exploited, right? You're using this library, and somebody got an exploit into the library, and you're exploited. That's how we think about it. Then what kind of happens is somewhere along the line, someone discovers the exploit, it is disclosed somehow, and eventually you get a vulnerability notification. So this is how we think about dependencies. You use it, and it has an exploit, you're exploited, all right? But there's a saying about if a tree falls in a forest and nobody hears it, doesn't make a sound. So I ask, if a library has an exploit added to it, but nobody deploys it, is there really an exploitation, right? No one's actually been exploited unless it's been deployed. So let's revisit the first three steps I had before. You use library X and someone writes a vulnerability for library X. All right, let's look at what actually has to happen between step 2 and 3. So first of all, that version has to be released. So you can write it. It has to be released. It has to go onto a registry of some sorts. You don't notice it, clearly. You're not noticing it. You haven't reviewed it, so that's gone. Nobody else notices it. And then finally, you deploy it. So it's not until you've actually deployed that vulnerability that you become vulnerable. It's not just that it exists, which is it. So as a simple point, don't deploy new releases unless you or a lot of other people have actually reviewed them first. Stop taking blind updates of third-party dependencies into your code. So the next question, why are we so bad at reviewing code today? Right? Because we are actually pretty bad at it. So the main reasons are there is actually no convenient way for people to review third-party code. You have ways to review your own code, but when you take a new version of somebody else's code, a dependency, it's just like one line in a dependency file, version 3.10 to 3.11. There's no convenient interface that exists yet to actually let you review that third-party code unless you go hunting for it. Number two is that there's actually doubt about the veracity of source code. So you can go and look at that module on GitHub where it has its source, but actually the source that you see on GitHub is not necessarily what gets released to the registry, like NPM, Maven, and Python, and things like that. There actually can be a gap between what is published and what is written, and bad people have actually already exploited that gap. So you could be reviewing code, source code, and that actually doesn't match what, it doesn't have the vulnerability in it that is getting pushed to the registry. And then the final part is that we have no concept of community sharing, right? Like, it's like when you review code today, it's like a TripAdvisor for one. I mean, it's like you're writing reviews of hotels just to remind yourself not to go to that hotel again, right? There is a certain motivation where when you have the ability to review or rate something, that other people are going to see it. And so the ability that there could exist a system for people to share that type of data would be very motivating to others. So here's one of the things we're working on. Easier dependency review. We want to display a verified source update so that when you do take the time to review it, you know that you're actually reviewing the code that's going to go into your project and not the code that the attacker has kind of faked on GitHub. You want approvals to flow back into your project. So when you click through, you review the software, the pull request to update that reflects your review. You want that automated rather than something you have to do manually. Especially if that library is used in 20 of your projects. You don't want to have to find all 20 projects and find the pull requests and individually say, yeah, I looked at it. Right? All right. So now we get to talk about like an efficient market theory for vulnerabilities. So the efficient market theory for share markets says there's no point looking deeply into shares because all the information available about a company is already priced into the share price. Well, in software dependencies, I think everybody these days assumes that there's no point looking for vulnerabilities because someone else would have found it already. And that's just really not the case. So we're introducing a concept called crowd dependency review. This enables the default sharing of review statuses, meaning that if you give a dependency a thumbs up or a thumbs down, a version, that is something that, unless you have a reason to withhold it, gets propagated out to the community, meaning that review once, shared everybody. We would need a reputation-based scoring of reviewers. Like any platform or any community, you don't want people to just game it with bots. You don't want someone to release an exploit and then have 20 sock puppet accounts reviewing it. Importantly, because we started talking about like risk and security, for the majority of us who can live with the late adoption of updates, meaning I can totally wait 1 or 2 weeks to get this update. We want those people to be able to harness the ability of crowd data, where it says 100 people have looked at this, 50 companies have updated, and 0 have rolled back. This is really strong data that says to you, this is a safe dependency to update. And in a perfect world, we'd actually start catching some of these exploits before they're deployed. Because today, we generally take it for granted that if somebody gets an exploit into the ecosystem, then it just propagates out, and all the unlucky people that use that library get hit. And this is a very flawed security model. So I want to talk about why now crowd reviewing or crowd security reviewing is something that really makes sense in the open source world. And I'll start by kind of saying things that wouldn't work. So the first is that sometimes people have the idea that we could remove the bad people from the equation. But the reality is you cannot remove all the bad actors, right? Even if you have some kind of approved list of trusted open source authors, accounts can still get hacked, or people can still deliberately appear trusted for a while because they plan to steal your Bitcoin next year. So it's really not plausible to think that we could solve our security problems by like having some kind of trusted sources of open source software. Now, the next idea sometimes people have is they say, well, we've got registries, so maybe we should be doing more on the registry side. And if you use JavaScript, you'd be familiar with like npm.js, and people have a great expectation on npm. When the exploits are published and they're discovered, people often immediately say, why didn't they stop it? right? We have this exploitation that there can be this gatekeeper that detects and stops exploits. But the reality is that some kind of mandatory OSS, open source code review, this would slow open source just to the speed of a turtle, right? So this is just really not feasible, that there can be some gatekeeper that reviews all of the code, as part of their duty. So what that means is that exploits and bugs, they will exist. This is guaranteed. So the software that you use will have exploits some days, and it will have bugs. So really, we need to rethink how we deal with that. I think one of the important concepts is that open source is free, and you can use it for free. But the important concept is that those who use open source should be responsible for reviewing it. Right? So if you're a company who uses third-party free open source components, asking that or suggesting that you review updates and share that you've reviewed it is quite a small ask, considering what you're getting for free. The next part is that somebody's got to walk around the corner first, right? So somebody has to take that earlier risk, and really that should be those who need it the most. When you're waiting on a feature, you're waiting on a fix. When there's a new version of software and it says nobody has reviewed this yet, if you want it, you really should review it. I mean, you can take the risk, but those who go first need to shoulder the risk. This also makes sense. But most importantly, this idea that we can review software, review updates, and share the results of that to build up a safer, community, to build up a community safety. This actually doesn't rely on moral arguments. It doesn't rely on charity. It doesn't rely on saying to for-profit companies. It doesn't rely on us saying, hey, you've got a responsibility to help the open source world with this, or to donate money. It just relies on people acting in their own self-interest, meaning that it's in your interest it's in your interest to stay up to date. But it's also in your interest not to deploy code that hasn't been reviewed. So you go first, you review it. So all the things we've described don't rely on people or companies, importantly, acting against their natural interests. All right. So, wrapping up, keeping your dependencies up to date is good. As a general one, if you can minimize the risk, then being up to date is the best way to stay ahead, or at the very least, stay closely behind exploits. Number two is that the risk of vulnerabilities is not that they exist somewhere, it's that you deploy them. So it's important to think what the steps happen between somebody publishing an exploit and you deploying it, and how you can get in the middle of that rather than waiting until after it happens. This is an important conceptual change in how we treat open source security. A third one is don't early adopt unless you review it first. And I think this will be something like, these days nobody would push software to production without running CI tests first, right? I mean, once upon a time, people didn't run as many tests as now. But nowadays, it's good, solid software practice to always run tests. And tests should pass, right, before you push live. I think this concept that you shouldn't also bring new versions of third-party dependencies without either A, reviewing them, or B, having a very high confidence level based on other people's reviews. I think this is also going to become a software best practice. This update of blindly updating software and assuming that everyone else is looking at it, these are over. So don't assume that everybody else is reviewing. And then the final point is that nobody can do it on their own. Even for-profit companies do not have the resources to literally review every single update of every single piece of software that they use. And this is why it's important that people participate in some form of community so that as a group we can get a better safety towards updates, rather than just everybody having to take the risk or do it all on themselves. All right. So thank you very much. If for some reason you'd like to strike up a conversation, my details are here. And if there are any questions right now, then I believe that we do have microphones, if anyone wants to ask something.